Hello everyone, myself Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. In this session, we are going to talk about multi-threaded programming. It is very important feature of Java that actually helps Java to make more than one task run parallel to each other. Now, what do you mean by run parallel to each other? Let me demonstrate you with this example. Consider. Okay, now consider this particular program. What we hear is we have class A, and class A contains function F1, a non-static function. In class A F1 function, we have for loop I goes from 1 to 10, and 10 time it will display high. That's it. It's a simple code. Class A has a function F1 where 10 time it will display high. We have another class B, same function F1. It could have been different function, but just for the sake, I have given the same name. So it's like F1 function in both class A as well as class B has same name. Okay? And again, it has a for loop from 1 to 10 and it displays high. Hello. So when F1 function of class A is called, it will display 10 time high. And when F1 function of class B is called, it will display 10 time hello. I just have to create object of the class. See, I have created object A1 equal to new A, B1 equals to new B, and I've called A1 dot F1 and then B1 dot F1. So since I have called F1 of A first, output will be 10 time high, next output will be 10 time hello. And now it is okay here in this case. Problem arises when, consider now. Now problem arises in this case. Now please have a look. Now same we have class A, please concentrate here. We have class A, we have F1 function. We have F1 function of class A. Here again 1 to 10 and 10 time hello. But there is a small piece of code here. Try catch. There is a try catch, and in try I've written thread.sleep 500. See, remember, when a function is called, it means that the processor is allotted to the function. Now sleep is a static method of class thread. We will see the method in detail, but for the time being, try to understand. Now when you say thread.sleep, now what will happen is after I equals to 1, I less than equal to 10, I less than equal to 10, yes. Now before it displays hello, it will go to sleep for 500 millisecond, means it will release the processor for 500 millisecond. So every time in every iteration of my for loop, before it displays hello, it will leave the processor for 500 millisecond. Means there is, let's say 10 times, so 500 into 10, approximately 5000 millisecond delay. It's 5-second delay when A F1 will be called, and then when B's F1 will be called again before displaying every high. We have try catch, and in try we have thread.sleep 500. Now why this thread.sleep is written in try catch? As we have discussed in exception handling, it is capable of generating interrupted exception. So if I am not writing it into try catch, then I have to write here throws. Then I have to write here throws next to F1 throws. I don't want to write there. I say. So what I've done is I have included it in try catch block. Okay, so this is it. Now what the point here is, when I call A.F1, hello will be displayed 10 times, but with a delay of 5000 millisecond. And then after that control goes to B F1, and then high will be displayed 10 times again with a delay of 5000 millisecond. So overall delay 5000 plus 5000, minimum delay of 10,000 millisecond, that's 10 seconds. Now that is what is bad here. Now what I wanted here is if something can be done such that when AF1 is in sleep, then B, since they are mutually exclusive. See, both the functions are mutually exclusive. It's not like that A class F1 gives some output that is taken as input by B ka F1. It's not like that. My both the methods are mutually exclusive. So can we visualize something like this? Ki when A ka F1 is in sleep, can we make B ka F1 to execute? Can we make the processor to access B ka F1? And when B ka F1 is in sleep, can we make the processor to access A ka F1? Now, this was not happened up till now. What we have studied up till now is when a function is called, the function will complete its execution, and then the control will return back to the caller. That is okay and accepted as long as there is no delay at the processor end. See, in the first case, when there was no thread.sleep, I was okay with the output. Okay, first we would have 10 time high, hello, and then we would have 10 time high. That is okay. But now in this case, before every display, there is a sleep of 500 millisecond. It means that for every display here, we lose 5 seconds and sorry, 0.5. And similarly there. So, and since both are exclusive, so I am desiring something. I am desiring that when the F1 of A is in sleep, when the thread.sleep is executing for 500 millisecond in F1 of A, can we make the processor to switch to B F1? And if we can do so, then it will be like hello and then high, then hello, then high, then hello, then high. We will make these two functions execute parallel to each other. And if we can do so, we are creating thread. This is what multi-threading is conceptually about. You're making more than one method run concurrent, and we can do so if and only if the methods are mutually exclusive to each other. So let's say, how do we do that? Now consider the same example here. See, class A, before every hello, there is thread.sleep. Here, before every hi, there is thread.sleep. Now, I want to convert it into thread. I want to convert it into thread. How to do so? So this is one way of doing it. So if you want to convert it into thread, so your task is basically, now first identify your task. Your task is what? Your task is basically F1 function of class A and F1 function of class B. So this is one way of doing it. First, make this F1 function, it should be, okay. First, make your class inherit thread class. Now, thread is a class that belongs to lang package. So we'll make step one, we will make class A extends thread. And then we will make class B extends thread. Okay, this is step one. Step two, that function should be run method of thread class. Now, thread class has a default version of run method. We need, when we intend to create multi-threaded application, we have to override the run method of thread class. Now, the run method is public in thread class. So while overriding, it should be public here. So what I'm supposed to do now, instead of F1, what I'm supposed to do is I'm supposed to write public void run. That's it, only two change. First, you make the class extend thread class, and then you override the run method of thread class. Okay. Similarly here, we have public void run. So this is at the class, and first you make your class extend thread class, then you override the run method and write the logic within this run method. Similar for class B, it extend thread class, it overrides run method and writes the logic within run method. Now there is a point here. Now here we have A dot F1 and B dot F1. We cannot do so now because we don't have something called as F1 function. Now what I'm supposed to do is, you're supposed to make it like this. See, now what I'm supposed to do is, I am supposed to call A1 dot start and B1 dot start. Now there will be a question. So the name of the method is run. Then why we are calling start method? We will understand it. But for the timing, this is what you should understand. Step number one, create a class that extends thread class. Step number two, override the run method and write the thread logic within it. Step number three, create object of the class extending thread class. Step number 4, using that object called start method. And I've done this for class B also. See, we created a class that extends thread class, we overridden the run method. We created object of class B. We created object of class B, and we have called start method. Now this is creating multiple thread using, by extending thread class. Now we can do so same by another way, and let's see that. Now here also, now instead of class extending thread, I am writing implements an interface known as Runnable. It implements an interface known as Runnable, and this method should be run method. Similarly here. So it means that you can also always ask me, sir, but in last example, you said that run method belongs to thread class. Well, run method belongs to runnable interface also. Runnable is also a built-in interface. And this is another way of creating thread. So we created a class that implements runnable interface and public void run. So step number 1, we created a class that implements Runnable. There we created a class extending thread. And then we have overridden the run method in both the case. Now what was happening is there, just see, in this particular example, we created class A object and we called start method. The basic idea is the start method is a method of thread class. Now here in this case, class A and B both are extending thread. So A object and B object are nothing but thread object. So using thread object A1, B1, can we call start method of thread class? Yes. Now in this case, what happens is here class A and B, they are not inheriting thread class. So A object and B object are not thread object. But start method has to be called using thread object. So what we are supposed to do, if in a case you have a class that implements runnable interface, next step is create object of the class implementing runnable. So class A implements runnable, I created class A object. Class B implements runnable, I created class B object. Now what you're supposed to do is for these two classes that implements runnable, we will create corresponding two thread object. So we have thread T1 equal to new thread, and we passed object of class A that implements runnable. Thread T2 equal to new thread, another thread, and we passed B1 object of the class implementing runnable. So now here we have object T1, a thread object referring to A1, which is object of the class implementing runnable. We have thread T2, thread object referring to B1, which is again object of the class implementing runnable. And now we have two thread object corresponding to each of these class that implements runnable. We can call start method. And this will make these two methods run concurrent with each other. So this is about creating thread. Step, you have two methods. First by extending thread class and by implementing runnable interface. If it is by extending thread class, create a class that extends thread, override run method. Step number 3, create object of the class extending thread. And fourth, using that object called start method. The basic idea is start is called by thread object. If my class inherits thread class, my class object is a thread object. But if my class is implementing runnable, then there is one more step required. For this class that implements runnable, you have to create corresponding thread object. And then using that thread object, we will call the start method. We will continue this in the next video. For detail, you can always refer to Herbert Schild, the Java 2 complete reference. Thank you very much.